You guys, today's modeling chemical reactions. Okay, we had to see that chip. The iron comes from the chip and oxygen comes from the surrounding water. Talking about this. Also here, continue next page. How is the rusting of the wreck? Well, it's iron, oxygen, and rust. As well, model it. The molecular model and chemical equation represents the formation of ammonia. Okay, look, nitrogen and hydrogen. It will be 2 and H3. Also identify with circle the product, which is this, with the coefficients underline 2 and 3. 2. Interpret models how many of the hydrogen in one molecule of ammonia, 3 hydrogen atoms. It says, are any atoms created or destroyed this reaction? The answer is no. The number of atoms of each is the same in the products as in the reactants. Combustion. Combustion is the flames here as well. Okay, now record the names and the formulas of reactant products of methane combustion. Reactants, methane, oxygen, products, carbon dioxide, and water. Law of conservation of mass. It says, looking at this figure 4, mass conserved, here separated the iron sulfate, but here is already on the product. Says figure 4, explain how the masses on the schedule. Figure 4 demonstrate the law of conservation of mass. The sum of masses and reactant equal to the mass of product. Next page. Valence equations. Okay, we need to find proportional relationships match each description shown chemical equation as it describes. None of the atoms in valence, that will be D. Oxygen atoms not valence will be C. Iron atoms not valence will be A. And all the atoms valence will be B. Okay, that's it for this page. Next page. Types of chemical reactions. Okay, we're talking about synthesis, decomposition, and replacement in this page. And the academic vocabulary says in life science that decomposition of matter occurs after something dies. Okay, when write a sentence that uses the word decomposition. This is a good example. Decomposition is at work in the school compost pile. Now let's look at the car. Rusting car. Rust forms on this car as a result of reaction between iron and oxygen. What kind of chemical reaction do you think produces this rust? Okay, it is a synthesis reaction. Two different reactants combine to make a single product. Okay, and finalizing lesson 3, identify aluminum. Okay, we have the formula all silver tarnish Ag2S. Yield pure fuel is Ag and aluminum sulfide. Here we can see the formula. What are the reactants and products in this reaction? Reactants are aluminum and silver tarnish. Products are silver and aluminum sulfate solution. 2. Is the reaction above a replacement reaction explained? Yes. It replaces silver in the compound with sulfur. 3. According to the law of conservation of mass, why must a chemical equation be balanced? All atoms in the reactant must be present in the product because no matter is created or destroyed in a chemical reaction. Now, number 4. A neighbor wants to use his backyard garden to conduct an investigation on how tomato plants use specific amounts of carbon dioxide and water to grow at a certain rate. Is it a good idea? The answer is no, because the backyard is an open system. It won't be able to measure the control amount of carbon dioxide around the tomato. He may be able to use the movement of water in and out of the system, but seems difficult to. 5. The chemical equation in this case will be carbon and oxygen. So here it is when they bond as a product. Okay, for carbon dioxide. And finalizing, you learn about law conservation, math, how to model chemical reactions using equations. You also learn about different types of reactions and the impacts of open and closed systems. What type of system should your pot use? An open system or closed system? The answer will be a closed system. If the reactant products can flow in and out of the system, it will be difficult, if not impossible, to control the reaction, how the heat flows in and out of it. Thank you. That's it, guys, for lesson 3.